Welcome to sureshbhattclasses. We are solving question on quantitative aptitude topic numbers. All the topic of quantitative aptitude are useful for all competitive exams like bank PO, RRB, SSC CGL, railways and many government job exams and job interviews. The topic of quantitative aptitude are also useful for many entrance exams like GRE, SAT, ACT, CAT, GMAT and many more. Please watch all my videos of quantitative aptitude topics. In this video, we are going to solve questions on finding number of factors. Our question is, find number of factors of 1500. The given options are option A 30, option B 24, option C 26, option D 28. Before solving this question, I request you to please subscribe to this channel. First we will factorize 1500 into prime factors, and 1500 can be written as 15 multiplied by 100, and this is equal to 15 can be written as 3 multiplied by 5, and 100 can be written as 4 multiplied by 25, and 4 is 2 to the power 2 and 25 is 5 to the power 2. Now this can be written as 2 to the power 2 multiplied by 3 to the power 1 multiplied by 5 to the power 3. This way we can easily find the prime factors of 1500. Now total number of factors are, the power of 2 is 2, so we can write it as 2 plus 1 multiplied by power of 3 is 1, so it is 1 plus 1, and power of 5 is 3, so we can write it as 3 plus 1. These are the total number of factors of 1500. This gives us 2 plus 1 is 3, 1 plus 1 is 2 and 3 plus 1 is 4. So it is 3 multiplied by 2 multiplied by 4, and 3 times 2 is 6 and 6 times 4 is 24. So there are total 24 factors of 1500, and from the given options our answer is option B 24. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find number of even factors of 144. The given options are option A 12, option B 9, option C 8, option D 10. Before solving this question, I request you to please subscribe to this channel. Any even number is of the form 2n. So whenever any number is multiplied by 2, it becomes even number. So what we will do, we will write 144 in the form of 2n. This is equal to 2 multiplied by 72. Now we will find the prime factors of 72. 72 equal to, 72 is 8 multiplied by 9, and 8 is 2 to the power 3, and 9 is 3 to the power 2. So these are the prime factors of 72, and we know that number of factors we can find by adding 1 to the power of prime factors. So the power of 2 is 3, we write it as 3 plus 1, and power of 3 is 2, so we write it as 2 plus 1, and this is equal to 4 multiplied by 3, and 4 multiplied by 3 is equal to 12. So there are 12 even factors of 144, and from the given options our answer is option A 12. Whenever we have to find number of even factors of any number, we have to take 2 out of that number, and then the remaining portion of that number is prime factorized, and whatever may be the power of prime factors, we add 1 to their power and multiply all those numbers, and we get the number of even factors. Like we have done here, we took out 2 from 144 and we wrote it as 2 multiplied by 72. Now we factorized 72 into prime factors, and the power of 2 was 3, we added 1 to 3, and power of 3 was 2 and we added 1 to 2, and that gave us 4 and 3. So 4 multiplied by 3 is 12, and that is the number of even factors of 144. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find number of part A, 2-digit numbers which have only 2 factors. The given options are option A 21, option B 18, option C 15, option D 12. Part B, 2-digit numbers which have only 3 factors. Option A 2, option B 3, option C 5, option D 4. Part C, 3-digit numbers which have only 3 factors. Option A 9, option B 11, option C 13, option D 7. Before solving this question, I request you to please subscribe to this channel. Part A, 2-digit numbers which have only 2 factors. The 2-digit numbers starts from 11 to 99. Now, from the definition of prime numbers, the prime numbers are those numbers which have the factors 1 and itself. So, all prime numbers have only 2 factors, and if we have to find 2-digit numbers, then we have to find all prime numbers from 11 to 97, and those are 21 numbers. And from the given options, our answer is option A 21. 11 to 97, there are 21 prime numbers. Part B, 2-digit numbers which have only 3 factors. 2-digit number which have only 3 factors, those numbers are square quantities, and if it is square of any number, then it will be 2 plus 1, that will be the number of factors, and that number must be a prime number. So the square of prime number which has 2 digits will be our answer. The square of 2 is 4, which is 1-digit number. Square of 3 is 9, which is 1-digit number. 4 is not a prime number. 5 is a prime number. So square of 5, which is 25. So 25 is the first number, which is 2-digit number and has 3 factors, 1, 5 and 25. Now next number is 7. 7 times 7 is 49, and 49 is a 2-digit number which has 3 factors, 1, 7 and 49. Now after that, the next prime number is 11, and the square of 11 is 121, which is a 3-digit number. So we have only 2 such numbers which have 3 factors, and those are 25 and 49. So for part B, the answer is option A 2, and those 2 numbers are 25 and 49. Now we go to part C, 3-digit numbers which have only 3 factors. We have the same logic. It must be a square of a prime number, then only it will have 3 factors. And the square of 11 is 121, is a 3-digit number, 111 and 121. These are the three factors of 121. Then square of 13, which is 169. It has three factors 1, 13 and 169. Then square of 17 is 289. It has again three factors 1, 17 and 289. Then another prime number is 19. The square of 19 is 361. 361 is a 3-digit number which has factor 1, 19 and 361 itself. Next prime number is 23, whose square is 529, and 529 is a 3-digit number which has three factors 1, 23 and 529. The next prime number is 29, and the square of 29 is 841, and 841 is a 3-digit number, has three factors 1, 29 and 841. The next prime number is 31, and square of 31 is 961. 961 is a 3-digit number and has three factors 1, 31 and 961. So these are 1, 2, 3, 4, 5, 6 and 7. These are 7 3-digit numbers which have three factors. And part C has answer option D 7. So these are the answers of this question. Part A has answer 21, part B has answer 2 and part C has answer 7. I hope you have understood the method of solving such type of questions and the concept involved in solving this question. We go to the next question. Our question is, which of the following numbers have maximum number of factors? The given options are option A 84, option B 360, option C 408, option D 468. Before solving this question, I request you to please subscribe to this channel. Looking to the options, the greater number should have maximum number of factors, but we will check it whether it is correct or not. 84, when factorized for prime factors, has 2 to the power 2 multiplied by 3 multiplied by 7, has factors 2 plus 1, that the power of 2 is 2, so it is 2 plus 1. Power of 3 is 1, so it is 1 plus 1. And power of 7 is 1, so it is 1 plus 1. 2 plus 1 is 3, 1 plus 1 is 2, 1 plus 1 is 2. So 3 times 2 is 6 and 6 times 2 is 12. So there are 12 factors of 84. Now we factorize 360 into prime factors. 360 has 2 to the power 3 multiplied by 3 to the power 2 multiplied by 5. 2 to the power 3 is 8, 3 to the power 2 is 9. 8 times 9 is 72 and 72 times 5 is 360. So these are the prime factors of 360. Now we can find the number of factors. So we add 1 to each power. So power of 2 is 3, so we add 1 to it, 3 plus 1. Power of 3 is 2, so we add 2 plus 1. And power of 5 is 1, so it is 1 plus 1. 3 plus 1 is 4, 2 plus 1 is 3 and 1 plus 1 is 2. So it is 4 multiplied by 3 multiplied by 2. 4 times 3 is 12 and 12 times 2 is 24. So 360 has 24 factors. Now 408. 408 has prime factors 2 to the power 3 multiplied by 3 multiplied by 17. 17 times 3 is 51 and 2 to the power 3 is 8. 51 times 8 is 408. It has number of factors. We add 1 to each power of prime factors. So this is 3 plus 1. 3 has power 1, so it is 1 plus 1. and 17 has power 1, so it is 1 plus 1. This is 3 plus 1 is 4, 1 plus 1 is 2, and 1 plus 1 is 2. So 4 times 2 is 8, 8 times 2 is 16. So 408 has 16 factors. Now 468. 468 equal to 2 to the power 2 multiplied by 3 to the power 2 multiplied by 13. 2 to the power 2 is 4. 3 to the power 2 is 9 multiplied by 13. 13 times 4 is 52 and 52 times 9 is 468. 52 is 50 plus 2. 50 times 9 is 450 and 2 times 9 is 18. So 450 plus 18 is 468. This way you should do the fast calculation. Now we have to find the number of factors. So we have to add 1 to each power of prime factors. 2 has power 2, so it is 2 plus 1. 3 has power 2, so it is 2 plus 1. And 13 has power 1, so it is 1 plus 1. 2 plus 1 is 3 and 2 plus 1 is 3 and 1 plus 1 is 2. So 3 times 3 is 9 and 9 times 2 is 18. So 468 has 18 factors. Now we have the number of factors for all the given numbers. 84 has 12 factors, 360 has 24 factors, 408 has 16 factors, and 468 has 18 factors. So maximum number of factors are in 360. And from the given options, our answer is option B, 360. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, A, B and C are three distinct prime numbers. Find number of factors of A multiplied by B multiplied by C. The given options are option A 3, option B 5, option C 6, option D 8. Before solving this question, I request you to please subscribe to this channel. As A, B and C are distinct prime numbers, so A don't have any factor other than 1. Similarly, B has one factor which is itself other than 1, and C has only one factor which is C itself other than 1. So it has power, A has power 1, B has power 1, C has power 1, and therefore the number of factors are 1 plus 1. We add 1 to each power. B has power 1, so it is 1 plus 1, and C has power 1, so it is also 1 plus 1, and this is equal to 2 multiplied by 2 multiplied by 2 equal to 8. For example, 30 has factors 2 multiplied by 3 multiplied by 5. These are three distinct prime numbers, and 2 has power 1, 3 has power 1, and 5 has power 1. So as shown above, it should have 8 factors. Now what are those factors? 1, 2, 3, 5, 6, 10, 15 and 30. So these are 8 factors. I hope you have understood the concept behind this question. And from the given options, our answer is option D 8. We go to the next question. Our question is, find the ratio of total number of factors of 504 and 240. The given options are option A 5:4, option B 3:2, option C 5:3, option D 6:5. Before solving this question, I request you to please subscribe to this channel. The prime factors of 504 are 2 to the power 3 multiplied by 3 to the power 2 multiplied by 7 to the power 1 Now we can find the number of factors of 504. We have to add 1 to every power of prime factors. So 2 has the power 3, so we add 1 to it. 3 plus 1 into 3 has power 2, so we add 2 plus 1. 7 has power 1, so we add 1 to 1. And 3 plus 1 is 4. 2 plus 1 is 3 and 1 plus 1 is 2. So this is 4 multiplied by 3 multiplied by 2. 4 times 3 is 12 times 2 is 24. 504 has 24 factors. Now we find the factors of 240. The prime factors of 240 are 2 to the power 4 multiplied by 3 to the power 1 multiplied by 5 to the power 1. Now we can find the total number of factors of 240. We have to add 1 to each power of prime factors. 2 has power 4, so we add 1 to 4, so it is 4 plus 1, and 3 has power 1, so we add 1 to 1, and 5 has power 1, so we add 1 to 1. 4 plus 1 is 5, 1 plus 1 is 2, and 1 plus 1 is 2. So 5 times 2 is 10, and 10 times 2 is 20. So 240 has 20 factors. Now the ratio of their factor is 24 ratio 20, and this is equal to 6 ratio 5. And from the given options, our answer is option D, 6 ratio 5. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, how many factors of 2 to the power 5 multiplied by 3 to the power 4 multiplied by 5 to the power 6 are odd numbers? The given options are option A 20, option B 35, option C 30, option D 42. Before solving this question, I request you to please subscribe to this channel. We know that the odd numbers are those numbers which are not divisible by 2. So in the given number, if we do not take multiples of 2, that is 2 to the power 5, and if we take all the factors of 3 to the power 4 and 5 to the power 6, so those will be, the power of 3 is 4, so we write 4 plus 1, and power of 5 is 6, so we write 6 plus 1, and 4 plus 1 is 5, and 6 plus 1 is 7. 5 times 7 is 35. So there are 35 factors which are odd numbers. This is the shortcut method of finding the factors which are odd numbers. The other method is, first we find the total number of factors, then we find the factors which are even numbers, and we subtract even number factors from the total number of factors. Then we can find the odd number factors. So the total number of factors are 2 to the power 5. The power is 5, so we add 1 to it. So 5 plus 1 is 6 multiplied by 3 to the power 4. So power is 4 and we add 1 to it. So it is 4 plus 1 is 5 multiplied by 5 to the power 6. The power is 6 and we add 1 to it. So it is 7. So 6 times 5 is 30. And 30 times 7 is 210. So 210 is total number of factors of given number. Now for even factors, what we do? We take out 2 from given number. So the given number can be written as 2 multiplied by 2 to the power 4 multiplied by 3 to the power 4 multiplied by 5 to the power 6. Now we will find the number of factors of 2 to the power 4 multiplied by 3 to the power 4 multiplied by 5 to the power 6. and 2 to the power 4, the power is 4 and we add 1 to it. 4 plus 1 is 5 multiplied by 3 to the power 4, the power is 4. 4 plus 1 is 5 multiplied by 5 to the power 6, the power is 6 and we add 1 to it. So 6 plus 1 is 7. And these are the factors which has even numbers. So 5 times 5 is 25 and 25 times 7 is 175. The total number of factors are 210. The numbers which are even numbers, those factors are 175. So if we subtract 175 from 210, that is 210 minus 175 is 35. So these are the numbers which are odd numbers, or these are the number of odd number factors of given number. This is the proper method of finding odd number factors. So I have shown it, the shortcut method as well as the proper method of finding odd number of factors. And from the given options, our answer is option B, 35. I hope you have understood the solution and shortcut method of solving this question. We go to the next question. Our question is, if total number of positive factors of 2160 is x, find the value of x minus 4 whole raised to power half or 1 upon 2. The given options are option A 5, option B 4, option C 6, option D 7. The x minus 4 raised to power half is nothing else, but we have to find the square root of x minus 4. Before solving this question, I request you to please subscribe to this channel. We have to find the value of x, which is the total number of factors of 2160. The prime factors of 2160 are 2 to the power 4 multiplied by 3 to the power 3 multiplied by 5. We can write it as 5 to the power 1. Now for finding the total number of factors, what we have to do? We have to add 1 to each power of prime factors. So we add 4 plus 1, the power of 2 is 4, so we add 1 to 4, and the power of 3 is 3, so we write 3 plus 1 multiplied by the power of 5 is 1, so we write 1 plus 1. 4 plus 1 is 5, 3 plus 1 is 4, and 1 plus 1 is 2. So 5 times 4 is 20, and 20 times 2 is 40. This gives x equal to 40. We have to find the value of x minus 4 raised to power 1 by 2, which is square root of x minus 4. So we put the value of x is 40 minus 4 whole raised to power 1 by 2. 40 minus 4 is 36, and the power of 36 is half, or we have to find the square root of 36, and that is equal to 6. So the value of x minus 4 raised to power 1 by 2 is 6. And from the given options, our answer is option C, 6. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, how many factors of the number 2 to the power 6 multiplied by 3 to the power 5 multiplied by 5 to the power 6 multiplied by 7 to the power 3 are multiple of 180? The given options are option A 480, option B 520, option C 390, option D 436. Before solving this question, I request you to please subscribe to this channel. We have to take out 180 from the given number. So first we factorize 180 into prime factors. The prime factors of 180 are 2 to the power 2 multiplied by 3 to the power 2 multiplied by 5, and we can write it as 5 to the power 1. Now we have to take out these prime factors from the given number. So given number is 2 to the power 6 multiplied by 3 to the power 5 multiplied by 5 to the power 6 multiplied by 7 to the power 3. Now we take out 2 to the power 2 multiplied by 3 to the power 2 multiplied by 5 to the power 1 from the above number. When we have taken out 2 to the power 2, then the remaining power of 2 is 4. So we write it 2 to the power 4. We have taken out 3 to the power 2. Therefore, the remaining power of 3 is 3 to the power 3. We have taken out 5 to the power 1. So the remaining power of 5 is 5 to the power 5 multiplied by 7 to the power 3. Now we can easily find out the factors of remaining portion, which is 2 to the power 4. So we add 1 to each power. 2 has the power 4, so it is 4 plus 1. 3 to the power 3, so we write it as 3 plus 1. 5 to the power 5, so we write 5 plus 1. And 7 to the power 3, so we write 3 plus 1. Now we multiply all these numbers. 4 plus 1 is 5, multiplied by 3 plus 1 is 4, multiplied by 5 plus 1 is 6, multiplied by 3 plus 1 is 4. And this is equal to 5 times 4 is 20. 20 times 6 is 120. And 120 times 4 is 480. So we have 480 factors of given number which are multiple of 180. And from the given options, our answer is option A. I hope you have understood the method of solving such type of questions. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.